Today we're going to focus on hyperbolas. We're going to learn how to graph them and how to find their equations. And we're going to focus just on the ones that are centered at the origin. Understanding that the next lesson we'll talk about how to translate them around a little bit, but very little. The focus on the test will not be on hyperbolas. Okay? So, just to review real quick, parabolas. Okay, the model for parabola is okay, where HK is the vertex. Right? This model is either going to open up or it's going to open down. Not both of them, just one or the other, depending on what?
Positive
Or
and
A
negative.
is positive.
Okay, so this is going to be if A is bigger than 0, and this is going to be if A is less than 0. Okay? The other model for parabola says x equals A y minus k squared plus h, where hk is still the vertex. Okay? Because the k is still with the y value, right? And so the h would be the x. Which looks strange because we're used to seeing it this way up here, and now they're switched around. And so the k is the y, and the h, which is outside now, is still the x. Okay? All right, the model of those, what they look like as a graph now, are this way, or this way, one or the other, depending on what? Okay, whether what is positive or negative? A. So this would be if A is less than 0, and this would be if A is bigger than 0. Okay? Now that's the parabolas. We've done a lot of work with parabolas. You have done a lot of work with parabolas. Okay, you even started parabolas in 8th grade in Algebra 1. Okay? Now, though, we're taking it to a little different level because I don't think you saw any of these in Algebra 1, did you? You're all either up or down, and they gave you equations in standard form instead of vertex form. Okay, let me pause for a second. So any questions on the parabolas? Okay, next thing we did then is we went to circles. And circles had the formula x minus h squared plus y minus k squared equals r squared. Okay? Where hk is our center, and r is the radius. Okay? I sometimes feel writing r is equal to the radius is not strong enough. Like I should be saying the square root of r squared is equal to r, which is equal to the radius. Because too often we see that number out on the end and we say, oh, that's my radius. But it's not really. It's really my radius being squared. So if I need to know the radius, then I have to square root whatever this number is. Okay? A little less involved with circles, wasn't it? I mean, they're all round. The only difference in them is how long the radius is, right? And where they are on the graph. And so really this is all we need to know. Do we have any questions on circles before we move on to reminding us what we did yesterday in ellipse? Okay? So yesterday, lesson 10.4, we did ellipse. We have a couple different models for ellipse. We have one where it's x squared over a squared plus y squared over, actually I'm going to change, I'll leave this. Over b squared equals 1. And remember that a is always bigger than b when it comes to an ellipse. A is always bigger than b when it comes to an ellipse. Okay? And so, in this model then, because the bigger number's underneath the x squared term, then that means my ellipse is going to, the major axis of my ellipse is going to be on the x-axis. So it looks something like this. Okay? Remember, this is the major axis. This was the minor axis. Okay? And the distance from the vertex to the center is A, and the distance from the co-vertex to the center is B. Right? The distance from the focus to the center is C, and C squared is A squared minus B squared. It makes me realize I forgot to mention the focus in the parabolas. We should probably go back and write that down. In fact, I'll do it right now. We should remember that the absolute value of A is equal to 1 over 4C, and C is the distance from the focus or directrix to the vertex. Okay? C is a distance from the focus to the directrix, from the focus or the directrix to the vertex. Remember, the vertex is exactly halfway between the focus and the directrix line. Okay? So C is the distance from that focus to the vertex and from the directrix to the vertex. Can I change pages or someone's still writing? Bless you. Okay, and remember with an ellipse, there are two focus points, and so they're called foci. Okay? And C is that distance. C is the distance from the center to the focus. Okay? Or to the foci, for focal. Now that was when the major axis is horizontal. This model is when the major axis is vertical, because A is always bigger than B. Whichever variable the bigger number is under, that's the axis the major axis is going to be on. So in this case, looks something like this. Now here's my major axis. Here's my minor axis. Okay. All the same rules with the foci and the distance between the foci and the center, and the distance between the vertex and the center, the distance between the co-vertex and the center. Those are all the same. This is still B. This is A now, this distance between here and there. Okay? And I'll just put one of them down here. This would be C, the distance from one of the focus points to the center is C. Okay? So that's what we worked on yesterday. Any questions on that? Yes.
How do you know which formula to use? Like whether you're using A, or not A, but x squared over A, or x squared over B. Like
Are you saying if they give me a picture of a graph, how do I know how to write the equation?
Or like that, or if you're given the formula for the equation, how do you know how to like graph it?
Which graph it is? Well, again, if I'm given this equation, x squared over 4 plus y squared over 9 equal to 1, the bigger number of these two is the 9, right? And it's under the y squared, so that means I'm looking at this model. If it was x squared over 9 plus y squared over 4 equal to 1, now the bigger number of the two is under the x, so I'm looking at that model.
Right. But like if they give you, if they don't set it in that form.
Well, if they say x squared plus y squared, let's change this. 9x squared plus 4y squared equals 36. Then I'm going to divide every term by 36 because this number has to equal 1 no matter which model I'm looking at. And so this is divided by 36, this is divided by 36. 9 goes in there 4 times, so I get x squared over 4. 4 goes into there 9 times, so I get y squared over 9. And 36 over 36 is, separate that a little bit. 36 over 36 is 1, so I got this model right here. Okay? So whatever numbers are in front of the x and the y, they're probably going to multiply together to give me that number that was out front. Don't always have to, but they probably are. Okay? Any other questions? I'm going to erase this, clean this up just a little bit. What did you start to ask me? Well, I'm going to try to keep them as simple as I can. That's why we're going back and reviewing. No, there's not a lot of vocabulary and that kind of stuff. It's more application. How do I apply the little things, the few things they gave me? Okay. So today we're going to talk about hyperbolas. Hyperbolas. That's I actually think that way when I spell it. Okay. Hyperbola is how it's actually pronounced, but I think of it as hyperbola, then I spell it properly. Okay? So hyperbolas, their models look much the same as the ellipse. What's the difference of it? I'm subtracting the two terms instead of adding the two terms. Okay? I'm subtracting them instead of adding them. All right? The other model looks like this. The confusing part of this is we just got done training you that A is always bigger than B. And now we're introducing hyperbolas where it really doesn't matter which one's bigger. What matters is which one is being subtracted and which one's not. Okay? So when we look at this model, since the x squared is first, because the x squared term is first, the model is going to look like this. Okay? And in the second one, because the y squared term is first, the y squared is first, so we're subtracting x squared from it. We're looking at this model. In both models, these are the vertex. In both models, those are the vertex. And the line that connects them is called the transverse axis. Hyperbolas have two focus points, just like parabolas, just like ellipse did. And so those foci are like an ellipse, they're in like a like an ellipse and like a parabola. I think of the focus as being wrapped around by the graph. So you have to wrap around them. So the focus points has to be out here where the graph is wrapping around it, here where this graph is wrapping around it. Okay? It needs to look like that. And the same up here. Since it's out here, we're wrapping around it. Over here, we're wrapping around it. Okay? So that's where our focus points go. The rule, they give you a definition. I'm not going to write it on the board. It's on page 563. If you want to write it down, go ahead. I don't think it's urgent that you write it down. I'm not going to be looking for it in your notes. I'm not going to have a quiz where I say, copy down the definition for a hyperbola. That's up to you whether you want to write it in there or not. But it talks about, you remember with the ellipse, we said the distance from the point on the graph to the focus plus the distance from that point to the other focus point always adds up to a constant. Today it's the subtraction of those two always add up to, they're always equal the same number. Okay? So if we subtract those two distances, I always get the same number. And it's not helpful in what we have to do with it, so I'm not going to worry about how to find it. Okay? So this distance, I'm going to make a little rectangle here. rectangles are really important for us to know how to graph this, okay? They're really important for us to know how to graph this. I sketched my graph first. You saw that, right? And so when I draw in these lines that I'm about to draw in, you may see that I did a pretty lucky job of graphing it. Or you might see that I should have done what I'm doing now first. My point, I'm just kind of giving you a little disclaimer about what's going on. But this is really how it should be graphed. If you draw these lines in, corner to corner, the diagonals of the rectangle, draw the diagonals into the rectangle and extend them out. Those are actually asymptotes in which the graph is going to begin to get really close to. Okay? These are the asymptotes. So as you look at this one up here, I didn't do a very good job, did I? My graph up here should be coming out this way. Okay? And this graph should be coming out this way. Based on these the square rectangles I put in there. Yeah, go ahead.
So eventually they're going to get really close to 180 degrees, but like,
Well,
they will
yeah,
never
no,
become
not
straight.
really. I mean, my box could look different. I could start with a box that looked like this, and so my lines go like that. And so, no, I wouldn't think they're approaching 180 degrees at all.
Oh,
They're just approaching this asymptote.
okay.
Okay, go ahead.
Did you get the rectangle by just going?
I just created a rectangle because I need to label some things on it for you so you know how to make that rectangle. Okay? I just made it up. Your question, especially if you're listening at home or you watch this again tonight, your question was about the rectangle, how I got the rectangle, and there is a way to get the rectangle, and when we do the first example, I'll make sure you understand it. But right now, I'm just trying to give you some notes to refer back to and what these different parts of it mean, okay? And where I'm getting them from in the equations. And that rectangle can look like, it can be a square, it can be a rectangle that's really long and really skinny. It could be a rectangle that's really tall and really skinny. It could be really tall and really fat. It can look whatever, depending on what these numbers are. That rectangle could be any shape, as long as it's a rectangle. Okay? And then when we draw these diagonals in, then we know where our graph is going to approach. Okay? So let me back up a few times and clean some of this out of here. Okay. Now my original black graphs here really don't match my lines. That's okay. All right, we'll get to that in a minute. Okay? What I want you to realize is where these numbers come from, and I don't graph these a lot, so I want to make sure that I don't say it backwards for you. Okay? Yeah. Okay. I want to make sure I saw it right. All right. So this distance from the center to the vertex on this graph is going to be A. Okay? You can't what? Oh. Yeah. underneath?
X.
X. And so notice that A was along the x-axis, wasn't it? This distance then, from the center to the edge of the rectangle is going to be B. Okay? That distance from the center to the edge of the rectangle is going to be B. You notice the B is under the y-axis, or under the y variable, so it's going to be the one that goes up and down. Now when we move down here, where's the A now? Under the y. So this distance from the center to the vertex here is A. So you might think of it this way. In this situation, Garrett, in this situation, A is always the distance from the center of the box. Can I call that rectangle a box? Are you okay with that? That's what I mean. The center of the rectangle to the vertex is always A. It might be up and down, it might be left and right. That's depending on whether A is under the y squared or A is under the x squared. If it's under the y squared, then that A value is going to be up and down. If it's under the x squared, like we had here, then that A value is left and right. Okay? All right. So the distance from the center to the edge of the box over here now is B, because the B is the one underneath the x squared this time. Okay? So why are these numbers important? Because they help determine how big my rectangle is going to be. Okay? They help tell me how big the rectangle is going to be. From the center of the rectangle, I go to the right B units. That puts me to the edge of the rectangle. So if I go left B units, that'll put me to the edge of the rectangle also. Okay? It'll put me right where I want to be. So it tells me how big to make the box, which tells me where my diagonals go, which tells me how to graph my hyperbola. Okay? Now there's one variable we've not talked about yet. What is it? C. C, senor. Okay? C, if I drew this in, let me do it in a different color. If I drew this in here, I would have a little right triangle there, wouldn't I?
Yeah.
And so that distance right there is C, which is also the same distance from the center of the box to the focus, or the foci, because there's two of them. I know it doesn't look it in my picture, but the distance of the hypotenuse of that little right triangle is the same length as the distance from the center of the box to the focus point, and then to the other focus would be the same. Okay? Any questions on that?
Use a darker color than yellow.
Should choose a darker color?
Than yellow.
Okay.
Like on that.
Sorry, I'll do that next time. So, here's the rule. C squared is equal to A squared plus B squared.
So that would be
So that helps you know where to find the foci now. C would be the distance from the center to the foci. The center of the box to the foci. And so I know A squared and B squared because they're right here. And so if I add those two numbers up and take the square root of them, I'll find C, the distance from the center to the foci.
So to see this basically what we did, we just changed the plus and minus.
Yeah. You see the dilemma here? I hope you see the problem. These four things we've learned are so similar in some respects and so different in other respects. It's going to be very easy to get them confused. You really have to sit down, look at your notes, go through them, and make sure you get it straight. Okay, Kendra?
Is that just the fire
It is. Yeah. And that's all it was yesterday, too, when we did the ellipse. It's just that the A's and B's were in different places, so we ended up with C squared was equal to A squared minus B squared, right? We didn't write that down, but in this model, oh yeah, we did. C squared was A squared minus B squared. Now today, because it's just slightly different, the value of C is this distance right here, and so that's going to be the distance of, it'd be the hypotenuse of that little right triangle, okay? All right, in my mind, I've covered all the notes you need to have for this. I want to do a couple examples for you, okay? So that you can see how to do some of the homework that we're going to give you, all right? So I'm going to turn the page, I'm going to pause for a second. Okay, number 5 looks like this. I selected this one because it's not in the right form yet, is it? We need it to be equal to 1, so I have to divide everything by 324. And again, many of you are used to just drawing one line over here like this and divide it by 324. And I strongly urge you not to do that because the model we're looking at, we need two separate fractions. So we don't want I thought I paused long enough between them. We don't want one division here, we want individual ones. So divide each one by 324. How many times is 36 going to 324? 9. 9 must go in there 36 times then. And so we get this. So is my hyperbola going to open up left and right, or is it going to open up and down? Left and right, up and down. How do we determine? Remember I said the A and B doesn't matter anymore, does it? This is always, the first one is always the A squared. Doesn't matter if it's the biggest one or not, it's the A squared.
Which one's being subtracted? X or Y?
Okay, so since the Y is first, and it's a positive, it's going to open up and down. Okay? So it's going to open up and down. Let's do this. What's A squared going to equal? 9, so A is 3. What's B squared going to equal? 36, so B is 6. We want us to graph this. I'm going to actually choose a graph here so that I can make it look a little neater. I forgot I enlarged this screen so people could see what I had on the screen a little better, and it's still enlarged. That's why my graph grid is so big here. So now we need to make our rectangle, okay? So A is under the Y squared, so I'm going to go from the origin, I'm going to go up 3 and put a dot there. We go down 3 and put a dot there. Those are also the what of my graph? What's that point called? The vertex. Not the focus yet. We haven't found those yet. But those are the vertex. Or the vertices, because there's more than one. Okay? Now, what does the B tell us? 6 to the right, 6 to the left. And so my rectangle rectangle is gonna look like that. Could I use those as what?
Points, like,
I could, but they're not really points on the graph.
I'd like to make like the corners like dots.
Yeah, I'm not gonna beat you up, however it helps you to think about that. I just want you to know the distance from the center. The distance from the center to this edge of the box, or the rectangle, has to be 6 because of that. And the distance from the center to this edge has to be 6. Okay? So now, if I draw my see if I can hit the mark. Really missed the mark over here. You notice their intersection should be right in the center of the rectangle, always. Should be right in the center. So any questions on what I've done so far, how I created my box and drew my lines? Yeah,
Well, like when we do this, do you want the box and everything?
yeah.
Okay.
Yeah, if you're asked to graph, I want you to graph it. And I may rethink what I gave you for an assignment. I will rethink it. I don't know. I don't remember what it was, so we'll get right to the point. We'll just be 4 or 5 of these probably. All right. So then when I go to graph this,
Then you just follow it down.
I didn't draw a very neat graph, but that's kind of what it looks like. Yeah, I didn't draw it very good. But it looks like that. So they asked me to graph it, that's what it is. If they asked me to find the foci now, that would be the other question. Find the foci.
Where's the formula?
Remember, the foci is c squared is equal to
A squared.
a squared plus b squared. So this was a 9 plus 36. So c squared is that 45? Square root of 45, which is 3 square root of, we'll do it over here. That's 9 times 5, so that's how I got 3 times square root of 5. Okay? But square root of 45 is almost 7, isn't it? Square root of 49, 7. So my focus is going to be right in here.
And that's the hypotenuse, right, of all those triangles.
Yep. Yep, that's exactly right. He's saying that's going to be this distance right there, if I drew a straight line. This was A, this was B, and that's C, and that's going to be the same distance as that. Okay? Yeah, that's all I'm going to do.